Morning and welcome to this typically Birmingham day. For the next 15 minutes I'm going to talk about how one of the UK's largest users of operational research uses OR to provide solutions to wicked problems with real impact, and that's the Ministry of Defence. And in this case, the organisation I work for, the Defence Science and Technology Lab. So my name is Duncan Stewart. I'm a team leader in the Land Battlespace Systems Department, and I'm going to tell you about the most interesting job that I've ever had. There we are. Right. So just a bit of an outline. I'll give a little bit of a personal introduction, and then a small snapshot of what the Dstl is and how we go about doing things. And talk a little bit about our technical partnerships, so that's how we work with academia, industry and other government departments. Just talk about something called operational analysis, and then use 3 case studies from my own department that show you some of the breadth of the types of work we do. I'll then take questions at the end and just give you a short summary after that. So a bit of a personal introduction. So I started my academic career here in Birmingham, just a few miles down the road, at the Aston Webb building up the top there. So I did geology at university, and then I went on and I did a PhD at Bristol in paleoceanography and geochemistry. And those little beasties there are called foraminifera. And in parallel, this is where my academic and sort of military career collided. I was looking for something else to do. And so I joined the Royal Marines Reserve and completed commando training in 2001, and then deployed to Iraq and Afghanistan. And then at the end of my PhD, I moved into the environmental consultancy, sort of geotechnical consultancy work area, and didn't enjoy it very much. And then, in a strange twist of fate, my second job ended up giving rise to my first job, and then I joined Land Battlespace Systems after deploying to Helmand Province for 7 months. So there's a little bit of a sort of a trot through my own history there. A little bit on what the Dstl is. It's a trading fund of the Ministry of Defence. We are civil servants. It's 100% contract funded. Effectively, we work like an internal consultancy where our time is paid for, and that makes us, I believe, more cognitive of how we spend our time and how we design projects and how we serve our customers. Our turnover last year, £630 million, of which £400 million, so 2/3 of it, is the management of the MOD research programme. 60% of which is actually outsourced. So this is not government inward focus. Inward focus. We work with other government departments like the Department of Health, obviously the Ministry of Defence, but we employ a lot of companies and small to medium enterprises. We have about 5,000 employees, and then a mix of sort of permanent staff, military and strategic partners. Our purpose there, to maximise the impact of science and technology for the defence and security of the UK. What does that really mean? We are the technical assurance for S&T to MOD and other government departments. And that's reflected in our vision, to be the first port of call for defence, security-related S&T within government. That's a bit about us. I mentioned technical partnership. These are some of the organisations that we've worked with and had contracts with in the past 12 months, and that's by no means exhaustive. And I've got 4 sort of quick examples of to give you some of the breadth of the work that we do that really exemplifies or is mirrored in the people that we employ. So, forensic investigation service for the police forces to look at illegal use of explosives. Some of which is from theatre, Afghanistan. Industry partnership to do soldier anthropometrics. measuring soldiers in order to design vehicles better. Integrated trials with industry and academia to look at chemical and biological dispersal moving around the underground system. You could probably easily anticipate why we could do that. Industry partnership to model the human contribution to defence capability, something which I think historically has been neglected because it's a lot harder to measure the human part of the system. So what is OA? OA is OR. In the defence industry, we call operational research operational analysis because post-Second World War, we already had a department called the OR department, so operational requirements. So we talk about OA, the terms are interchangeable. And I like that Louise and I got a very similar definition of what OA or OR is, and I've called it the application of scientific methods to the solution of military problems. And some of those problems are wicked problems. They're incredibly complex and, on face value, hard to define solutions for. And there's four ways that, just four examples there. So OA is used to support policy and planning. For example, the quinquennial Strategic Defence and Security Review. We use it to develop military capability through something called PAN-DLOD analysis. We love abbreviations. A little sideline, DLODs, Defence Lines of Development, are basically a number of factors that contribute to a capability. And traditionally, people thought that capability was equipment. So a tank is your military capability. But actually, in order to have that tank in theatre, you have a human component, so personnel, you have doctrine, you have a training component, you have a logistic component, and it goes on and on. So our analysis typically is focused at all of these factors that contribute to putting people on operation. We support operational commanders around the world, both in the UK and in theatre. We deploy people forward, and we have people in Afghanistan at the moment. And we use OA to develop concepts and doctrine. So, the way we do things. Here's an example of some OA techniques. I don't profess to be an expert on all of them. But it just gives you a bit of a breadth of both the hard side, the more numerical aspects of OA, and the softer side, which shouldn't be neglected. The power of any project or success is inevitably a product of how you use different techniques together, recognising that different techniques have limitations. So wargaming, modelling and simulation is quite common. So a combat model is, let's say, replicating a battle in a computer in order to sort of tease out the effect of treatments. If you change weapon systems, if you change the number of vehicles you have. Maths is obviously a key component. So probability of hit, probability of kill, given certain range, certain equipment, certain targets. Queuing theory. Ships coming into a port, how long it takes them to unload and reload, and how much that costs. Historical analysis, effectively a bit of a dustbin term that uses all of these techniques but applies it to what's gone in the past. Trials and experimentation, trials to support equipment procurement, new rifle, new helmet, new tank, whatever. Experimentation, I'll talk a little bit about later. But not to underestimate the value of some of the softer approaches, and benefits mapping is probably something that is used very, very widely. Where you have complex problems that need to be broken down into bite-sized chunks so that our customers can really have their own decisions given the information. So an example might be if I want to improve soldier effectiveness, do I invest in equipment or training? Do I buy a new rifle or do I teach soldiers to shoot better? I've got 3 case studies now, just to show you some of the work we've been doing. Case study 1, the multi-terrain pattern. Some of you have probably noticed that we've so the problem was Dstl were tasked with assessing a new camouflage for Helmand to balance the end member of desert and green zone, just up on the left there. And so we undertook a series of scientific trials looking at the human observation, time to detect, signature analysis, even aesthetics. And there's a series of different camouflage that was tested during the trial. And we worked with some of our NATO partners to understand what they were doing about it. And in 4 months, we had proven that the Multicam concept there was the most effective average, if you like. And from that, MTP was developed. And so 4 months later, soldiers were wearing that camouflage in theatre and to good effect. Case study 2, a little bit more on the procurement support, the medium term. So Warrior armour fighting vehicles being upgraded. And typically we are asked to provide technical assurance in various disciplines. So I've got lethality, survivability, thickness, system integration. Lethality is the weapon system, survivability is the protection. Signatures are noise, thermal, infrared. Systems, engineering and integration, how all those systems work together. And the following points are there. Represent sort of roughly how we approach projects. We're defining the requirements, looking at concepts, modelling and various demonstrators, trialling in the field, and all moving towards effectively upgrading this capability, but against what we expect it to be used for in the future. And then my final case study is Urban Warrior 5. So this is very much more sort of long-term looking, where we're using experimentation aspects of operational analysis to answer the question, how can the effectiveness of armoured infantry company group in 2020 be improved for urban major combat operations? What the hell does that mean? How can an armoured infantry company, so about 100 people, operate in an urban environment better, such that we achieve our mission quicker and we achieve less or no collateral damage. And there were 3 techniques used there. So live experimentation, so that's actually using troops in the field in France on a big urban terrain. So that's the top picture there. Virtual, so then recreating parts of that live experimentation with hypotheses and treatments to examine aspects in a virtual environment. A little bit like Call of Duty, only not quite. And then constructive, so combat modelling. So then, so going one step further and looking at some of those interactions and treatments, but using a different method. And then you combine the outputs of the 3, and the impact is that we are now in a position to do things better. So we update our doctrine and memories. One last slide before questions. So these are some of the things that I've worked on. Theatre data analysis, unmanned ground vehicles, helmet body armour trials, support operations, small arms, burden reduction. I'm currently a team leader of 2 teams, including a combat model. I'm also doing a postgrad certificate in military OR, and I'd like to do a support with it. Any questions?
Say I've shook the hand of a Marine. So, any questions for?
Yes.
You mentioned that you served in theatre as a Marine.
Yeah.
Do you think that's pretty much an essential requirement?
No. And actually, I've got a summary slide next. But I think one of my key messages is that there's no orthodox route into operational research. It happens that I have a bit of a sort of a generalist background. I have military experience and I have academic experience, but that is by no means reflective of the people that we employ. But being a generalist, allows me to do certain things while also having to rely on some specialists.
Any further questions? No, in which case,
I summary there. I prefer to leave on a high, if you like. So, OA work is challenging, varied, and has real impact. I describe Dstl as a bit of a pseudo-academic environment that encourages people to think innovatively. There are loads of opportunities for the idea of working with different organisations and training. Orthodox routes into OR are not necessarily the only routes into OR, and I hope I've managed to show this, but I think most importantly, it's the most interesting job I've ever had,